Welcome to this third class about goal condition reinforcement learning. This class will be dedicated to present the typology of different perspectives that apply to this framework. So I will distinguish four perspectives. The first one will be the skill learning or skill discovery or unsupervised reinforcement learning perspective. The second one will be the setter-solver perspective. The third, the contextual RL perspective, and the fourth, the sequential or hierarchical reinforcement learning perspective. But the main focus here will be to distinguish between what we call skill learners and goal reachers. And the point is that this distinction is not so easy. We will see why later on. So finally, to organize the literature in this domain, I decided to rather rely on the problem they address. Actually, skill learners will be systems where the evaluation consists in determining how well the agent covers the state or goal space, or eventually will consist in using downstream tasks, for instance, reinforcement learning task after learning some representation, to evaluate the agent. By contrast, goal reachers will be agents which are evaluated on a success rate, so they have a set of goals to reach and we evaluate how well they reach these goals. And this distinction is much clearer in papers, so just by reading the experimental section of the papers and determining whether the figures are about coverage or downstream task or success rate, you can see whether the paper is more about skill learners or about goal reachers. So my classification will be driven by the addressed problem. One point that makes it difficult to distinguish between skill learners or goal reachers, that I also call autotelic agent in the case where they set their own goals, is that in both cases, the environment comes with no reward. The idea is that a skill learner should discover what to do in an environment without a reward, and the autotelic agent should discover how to reach different goals in the absence of external reward. Finally, I must mention that the contextual RL perspective is a little bit different from the goal condition reinforcement learning perspective, because a context is something more general than a goal. So a goal condition RL is a specific case of contextual reinforcement learning. So let's start with the unsupervised reinforcement learning perspective. First, I want to stress the fact that different systems address different kinds of goal spaces. In general, in unsupervised reinforcement learning, you can have a state coverage objective. In that case, you don't even have a goal space, and the idea is just to maximize the entropy of the state distribution covered by the agent. So you maximize the entropy of the state distribution. There are a few algorithms that do this. But when you have a goal space, you can have different settings. First, there is the case where the goal space is equal to the state space. And here you have mutual information systems where the agent tries to maximize the capability to reach different goals given a state. That's the case of Diane, Vic, etc. And you have a setting where the state space is different from the goal space. And in that case, the state space can be stationary. This is the case, for instance, in Dexter Curious. Or it can be learned but stationary, okay, where in these examples, so you just learn one goal space representation. And finally, you can learn different goal space representations through time. And this gives rise to open-ended skill discovery. So in all these cases, the general objective is to cover the space of possible goals, but the goals can be the states. And in general, in skill discovery perspective, there will be a downstream objective. So you want to be able to reach any goal so that later on you can learn to reach specific hard goals or to do different things, such as maximize an external reward that depends on those goals. So a perspective about system discovering a diversity of skills. I won't go into the details of those systems because they are covered in the next lesson, but the general perspective is that you want to maximize some coverage or some mutual information or empowerment, where empowerment is a measure that is defined in this paper. And for instance, those systems here try to maximize some diversity, and this one does the same, but in the case where observation consists in images. Now let's move to the setter-solver perspective. You already saw this image in the previous lesson, so that's to distinguish goal-env setting and the autotelic agent setting. Okay, so the setter-solver perspective distinguishes a goal setter which can be the agent in the case of a phototelic agent or the environment in the case of a goal setting. And you also have a goal solver, which is a goal condition policy learned with reinforcement learning. So you have an entity that sets the goal, and then you have a standard reinforcement learning policy that try to achieve the different goals. And the general objective is to handle the agent with fixed or open-ended color-ranging capabilities. With this table, I wanted to show that there are many different solvers in the goal condition reinforcement learning literature. Here you have a list of algorithms used to learn the policy. Okay, in general, this is a standard reinforcement learning algorithm like Q-learning, TD3, soft actor critique, PPO, etc., etc. And what you can see also is that the architecture is growing through time. Okay, the solvers are sorted through time. Okay, and you can see that in the beginning you had some rather small neural networks to implement the solver. And if you look closely, you see that little by little the networks get bigger and bigger. And even at the moment, now these agents are using more and more transformer or diffusion policies, but they are not shown since this table stops in 2023. From the table, you can also recognize that some solvers take images as input. That's the case of those who use a CNN as input layer. And you can also see that rather few of these systems use insight experience replay, which is a system that will be explained in one of the next lessons. Finally, I wanted to stress that you can use reinforcement learning to train your solver, but you can also use imitation learning or evolutionary methods, and I won't cover much of these approaches. A word now about the contextual reinforcement learning perspective. Okay, so in contextual reinforcement learning, the reward depends on some context and not generally on the goal. And you have a probability of context, which is generally fixed. And you have to learn a policy depending on this context and on the reward that depends itself on the context. In general, the context distribution is unknown. It comes from the environment. And if you want to go further in this literature that I won't cover, the precursor is this paper from the group of Jan Peters. It was then formalized by this paper, and there are more recent instances such as Care or Space that you can see here. I won't go further in contextual reinforcement learning because my focus is on the case where the context is a goal. Finally, a word about the sequential reinforcement learning perspective. So, what distinguishes a sequential setter from any other type of setter is that when performing a trajectory, the agent will trigger a sequence of behavioral goals rather than just one before it reaches the final desired goal. There are different classes of setters. We will see this in a specific lesson, like feudal setters, graph-based setters, etc. The idea is that hierarchical setters are the most common type, and that's the case where there is a high-level policy and not just a sequence of goals or a graph of goals, as is the case with the graph-based approach. But the point is that I will devote a specific lecture to hierarchical reinforcement learning, so I won't expand much on that particular family. So I will just give a quick overview in the context of this lecture from the goal condition reinforcement learning perspective. And now what I want to present is a unifying perspective. If you want to have a general goal condition reinforcement learning template, what you always have is a setter that sets either a goal, a skill, or eventually a context. Then you have a solver, which is a policy condition on what the setter sets, and then it interacts with the environment. And you have different kind of policy learning signals, because in the case of skill discovery, generally you have some discriminative capability that set a reward so that the different skills are distinct from each other. In the goal reacher family, the policy learning signal is generally a reward for reaching a goal. And in the contextual reinforcement learning case, that's a reward that depends on the context. I want also to stress that I will use this template very often. And in this template, as was the case in the diversities unit paper, green box corresponds to something which is fixed, and the blue box corresponds to something which is learned. and I didn't use a color for the setter because it can be either fixed or learned. The last slide of this lesson is to better explain how I will organize the presentation of the literature in the next lessons. First, I want to stress that a big advantage of the setter-solver perspective is that all setters of a class could compared using an identical solver, so I will ignore the differences between the solver. What matters in this class is the setters. And I will distinguish 6 classes of setters: the non-image-based skill discovery setters and the image-based ones, the non-image-based goal setters and the image-based ones, and the non-image-based sequential goal setters and the image-based ones. For each of these classes, I will provide some list, and in the list I will mention the input type, so is it a state, an object, an image, or a combination of those things. I will also mention some evaluation criteria. Is it a downstream task? Is it hierarchical reinforcement learning? Is it reaching a set of goals? In that case, which set of goals, so the nature of the target goal set. I will also show you that there are different subtypes of setters depending on the mechanism that is used by the setter. And for image-based setter, I will also mention the type of latent state encoder that encodes the image into some latent representation. And that's it for that lesson, and just a glimpse about the references.